When I was initially applying to NASA, I had the opportunity presented to me to work with the soft robotics team, and I thought it was just an interesting take and a different way of looking at things. I had never really thought about soft robots or even really heard of them before.
So a soft robot is a robot that uses fabrics or soft materials like silicone and elastomers to make up the robot's structure. Soft robots are very much biologically inspired or mimic biological systems. The ocean has a large abundance of soft creatures, yet they can do amazing, amazing things and solve incredibly challenging problems. So when you look at a soft robot, what you see is something that was inspired by nature, by the animals around us, by ourselves even. Our muscles, for instance, are considered soft systems, soft fibers. So when you look at traditional robotics, what you have is hard linkages. A motor connected to another motor that's allowing the system to move around. It's very controlled. We know the lengths, we know the masses, we know how the robot's going to move. With soft robotics, you don't have those hard linkages. Since they can absorb impact, they're very safe to work around humans. So there's a lot of work going on to use soft robotics for working with and alongside humans, helping humans out. The project that we're currently working on is using soft robotics in space assembly tasks. This is building structures in space or on other planetary bodies.
The soft robot that I'm developing is a soft gripper that's going to bond struts together. By being able to bond and debond this adhesive, if you think in terms of Legos, you can take these struts apart and put them in any form that you want. Soft robots can also be used in habitation on the lunar surface or the Martian surface. Soft robots can be used in astronaut suits to help with dexterity and hand motion, or to lift heavy things. Soft robotics is obviously very reliant on robotic systems, and coming into my internship, I didn't have the greatest experience with that. However, I was willing to learn how to code, how to program software, how to work with hardware, and now I have a much better understanding. Interning is a fantastic opportunity.
Creativity is one of the most important components. If you're able to look at a problem and think of novel solutions for it and be creative about that problem, that's an obvious win for you and other folks around you.
From a young age, I was very heavily involved with art, just drawing sketches everywhere. I used to love dinosaurs. With engineering, I really feel that it's able to combine my love of creativity with a hands-on those sciences and mathematic applications, and it's kind of a love between the two.
Robotics itself is multidisciplinary. Many, many, many different fields come together for robotics. You have mechanical engineering, you have software engineering, you have physics, you have math. In particular with soft robotics, there's a lot of biology in there. And so all of these different fields kind of come together in robotics. Students don't necessarily understand that, and that's okay. But as long as they have the underlying capabilities to work in that type of environment, it tells me that they are absolutely fit for a job like this and other jobs here at NASA.
Being open to other people's ideas is very important. They bring in a certain perspective that you might not have, and it might make you go, oh wow, I didn't think about that in that way before. And it kind of opens your eyes to new ideas. By having that drive and that passion to figure things out, you can learn anything.